Forever chemicals, a silent threat, per and polyfluroalkyl substances, PFAS, often dubbed forever chemicals, are a class of synthetic compounds that have been widely used in various industries for their unique properties: water and oil repellency, heat resistance, and durability. However, these very qualities that make them so useful also make them incredibly persistent in the environment and human body. The problem: persistence. PFAS molecules are highly resistant to degradation, meaning they can persist in the environment for decades or even centuries. Bioaccumulation. They can accumulate in the human body over time, leading to potential health risks. Widespread contamination. PFAS are found in a variety of products, including non-stick cookware, firefighting foams, water-repellent clothing, and food packaging. They can contaminate water supplies, soil, and air. Health risks. Exposure to PFAS has been linked to a range of health problems, including cancer, increased risk of kidney cancer, testicular cancer, and other types of cancer. Immune system impairment, weakened immune response, making individuals more susceptible to infections. Reproductive issues, decreased fertility, low birth weight, and developmental delays in children. Hormonal disruption, interference with the endocrine system, leading to various health problems. Liver damage, impaired liver function. Taking action. To address the issue of PFAS contamination, governments, industries, and individuals can take the following steps. Regulation, stricter regulations on the production and use of PFAS. Research, continued research to understand the long-term health impacts of PFAS exposure. Consumer awareness, educating consumers about the risks of PFAS and encouraging them to choose PFAS-free products. Waste management, proper disposal of PFAS containing products to prevent environmental contamination. Water treatment, developing effective technologies to remove PFAS from drinking water. By taking proactive measures, we can reduce our exposure to these harmful chemicals and protect public health. PFAS, or per and polyfluroalkyl substances, are a group of man-made chemicals that have been used in a wide range of products due to their unique properties of being water and oil repellent, heat resistant, and stain resistant. Here are some of the common applications of PFAS. Industrial uses. Firefighting foams, aqueous film forming foams, AFFF, containing PFAS are used to extinguish fuel fires. Manufacturing processes. PFAS are used as surfactants, lubricants, and processing aids in various industries. Consumer products. Non-stick cookware. PFAS are used to create non-stick coatings on cookware. Food packaging. PFAS are used in food packaging materials to prevent grease and oil from seeping through. Textiles and clothing. PFAS are used to make fabrics water and stain resistant. Carpets and upholstery. PFAS are used to make carpets and upholstery stain resistant. Cosmetics. PFAS are used in some cosmetics, such as makeup and skincare products. Cleaning products. PFAS are used in some cleaning products, such as stain removers and carpet cleaners. It's important to note that due to their persistence in the environment and potential health risks, the use of PFAS is being increasingly restricted or phased out in many countries. PFAS can significantly affect other organisms and species. Much like humans, various wildlife species are exposed to PFAS through contaminated water, soil, and air. Research has shown that these chemicals can have detrimental effects on wildlife, including reproductive issues. PFAS can disrupt the endocrine system, leading to reproductive problems such as reduced fertility, abnormal development, and increased mortality rates in offspring. Immune system impairment. Exposure to PFAS can weaken the immune system of animals, making them more susceptible to diseases. Liver damage. PFAS can cause liver damage in animals, leading to impaired liver function. Developmental delays. PFAS can affect the development of young animals, leading to developmental delays and behavioral abnormalities. Population decline. In severe cases, PFAS contamination can lead to population declines and even species extinction. Studies have shown that PFAS can accumulate in the tissues of various animals, including fish, birds, mammals, and reptiles. This bioaccumulation can lead to high concentrations of PFAS in these organisms, posing significant risks to their health and survival. It's crucial to address the issue of PFAS pollution to protect both human health and the environment. PFAS can exist in both solid and liquid states, depending on the specific compound and temperature. Most PFAS are solids at room temperature, often appearing as crystalline or powdery substances. However, shorter-chain PFAS compounds can exist as liquids under certain conditions. It's important to note that the physical state of PFAS can influence their behavior in the environment and their potential for human exposure. PFAS are used in a wide range of products due to their unique properties of being water and oil repellent, heat resistant, and stain resistant. Here are some of the most common applications of PFAS. Consumer products. Non-stick cookware. PFAS are used to create non-stick coatings on cookware. Food packaging. PFAS are used in food packaging materials to prevent grease and oil from seeping through. Textiles and clothing. PFAS are used to make fabrics water and stain resistant. Carpets and upholstery. PFAS are used to make carpets and upholstery stain resistant. Cosmetics. PFAS are used in some cosmetics, such as makeup and skincare products. Cleaning products. PFAS are used in some cleaning products, such as stain removers and carpet cleaners. Industrial uses. Firefighting foams. Aqueous film forming foams, AFFF, containing PFAS are used to extinguish fuel fires. Manufacturing processes. PFAS are used as surfactants, lubricants, and processing aids in various industries. Wastewater treatment plants. Wastewater treatment plants can release PFAS into the environment, particularly if they are not effectively removed during the treatment process. Landfills. Landfills containing PFAS contaminated waste can leach PFAS into the environment, contaminating soil and groundwater. Due to their widespread use and persistence in the environment, PFAS can be found in various environmental matrices, including water, soil, air, and biota. Identifying the exact country that generates the most PFAS is challenging due to the complex global supply chain and the historical nature of PFAS production. Many countries have contributed to PFAS production and use over the years. However, the United States has historically been a major producer and user of PFAS, particularly in industries like firefighting, foam manufacturing, and textile production. It's important to note that PFAS are persistent pollutants, meaning they can remain in the environment for a long time. As such, the impact of PFAS pollution is a global issue, and many countries are now working to reduce their use and mitigate their environmental and health impacts. Governments around the world have recognized the serious environmental and health risks posed by PFAS and have taken various steps to address the issue. Regulatory actions. Stricter regulations. Many countries have implemented stricter regulations on the production, use, and disposal of PFAS. Phase out of certain PFAS. Some countries have phased out the use of specific PFAS, particularly those with known health and environmental risks. Drinking water standards. Governments have established drinking water standards for PFAS to protect public health. Waste management regulations. Regulations have been implemented to ensure the safe disposal of PFAS containing waste. Research and development. Funding research. Governments have invested in research to better understand the health and environmental impacts of PFAS. Developing innovative technologies. Research is being conducted to develop technologies for the detection, removal, and destruction of PFAS. International cooperation. Global agreements. Countries are working together to address PFAS pollution through international agreements and conventions. Information sharing. Sharing information and best practices to coordinate efforts and promote effective solutions. Public awareness and education. Public campaigns. Governments and organizations are raising public awareness about the risks of PFAS exposure and promoting sustainable alternatives. Education and training. Providing education and training to professionals such as environmental scientists, engineers, and healthcare providers to address PFAS-related issues. While significant progress has been made, more needs to be done to effectively address the challenges posed by PFAS. Continued research, stricter regulations, and international cooperation are essential to protect public health and the environment. If you enjoyed this video, please hit that subscribe button and ring the notification bell to stay updated on my latest content.